Hello everyone, my name is Adrian and today I'll be talking about the center of mass for a system of discrete particles. The center of mass is the point where the total mass of the system can be considered to be concentrated. You can think of it as the balance point. If we could place the entire system on a needle, the center of mass is the exact spot where everything would be perfectly balanced. Now, in a system of discrete particles, we're talking about separate masses of individual objects, each located at a specific coordinate. The position of the center of mass depends on both where the object is and how heavy it is. Heavier objects pull the center of mass closer to them, while lighter objects have less effect. To find the center of mass, we need two types of equations called moments, one about the y-axis and one about the x-axis. The equation about the y-axis is written as m sub y, which equals to the sum of m sub I times x sub I. This means we multiply each mass by its x-coordinate and then add them up. Similarly, the equation about the x-axis is m sub x, which equals to the sum of m sub I times y sub I. That means we multiply each mass by its y-coordinate and then add those results up. So it's just almost the exact same. Now, in both equations, m sub I represents the mass and xi, yi are the coordinates or locations of the objects. Aside from this, we also need a way to find the total mass. We can do this by using the equation m equals the sum of m sub I. Finally, once we have those values, we find the coordinates of the center of mass using the following two formulas. As a result, these give us the x and y coordinates of the center of mass, which is what we're looking for. Now, if we take a look at page 556, we can see example 3. We are told that we have three objects. A mass of 3 located at point -1, 1, a mass of 4 located at 2, -1, and a mass of 8 located at 3 and 2. Remember, our goal is to find the center of mass. So we need to find the moment about the y-axis first using the information that was given to us. A mass of 3 located at the point of -1, 1 will be written as 3 times -1. A mass of 4 located at 2, -1 will be written as 4 times 2. And a mass of 8 located at 3, 2 will be written as 8 times 3. Now we can multiply each term. 3 times -1 equals to -3, 4 times 2 equals to 8, and 8 times 3 equals to 24. Now, when we add them all up together, we get 29. Therefore, the moment about the y-axis is 29. Next, we want to repeat the exact same steps we just did, but this time about the x-axis. So let's take a look at our information again. A mass of 3 located at point -1, 1 will be written as 3 times 1. A mass of 4 located at 2, -1 will be written as 4 times -1. And as you guys have probably guessed it, a mass of 8 located at 3, 2 will be written as 8 times 2. Now, just like before, we need to multiply, and when we do so, we are left with 15. Therefore, the moment about the x-axis is 15. Now we can find our center of mass. Once we calculate everything, we are left with 29 over 15, comma 1, which if we convert to a mixed number, it becomes 1, 14 over 15, or approximately 1.93. This means that our center of mass is around the point 1.93, 1.